Welcome to my digital class Spherical Mirrors. In this session, we will learn how to solve problems based on mirror formula. That is 1 by f is equal to 1 by v plus 1 by u. In our previous class, we studied and we derived the mirror formula. In this class, we will learn how to solve few sums related to mirror formula and few sums related to magnification, which are repeated in various competitive exams and at the same time in various public examinations. What is mirror formula? 1 by f is equal to 1 by v plus 1 by u. This is the relation between object distance and image distance, and the focal length is nothing but mirror formula, where f is known as the focal length of the convex or concave mirror and u is the object distance and v is the image distance. Already you studied in your previous class magnification. Magnification is defined as the ratio of the size of the image to the size of the object. It is the ratio of size of the image to the size of the object is known as magnification. Okay, it is known as magnification, and magnification is denoted by the symbol m. M is equal to, see how do we define the ratio of size of the image to the size of the object is called magnification. Now magnification m is equal to height of image by height of object. It is the ratio, so there are no units. Are you clear? So height of image to the height of object. So hi by ho, where hi stands for size of the image or height of the image and ho stands for size of the object or height of the object. This is also equal to minus v by u, minus v by u, where v stands for image distance and u stands for object distance. Let us try to solve this problem. It is repeated in various annual examinations, in public examinations in various boards. An object is placed at a distance of 10 centimeters from a concave mirror. Try to understand the question carefully. It is placed at a distance of 10 centimeters from a concave mirror of focal length 15 centimeters. You are asked to find the position and nature of the image. Position and nature of the image. Whenever this type of problems are given, first you try to draw the diagram. Try to draw the diagram. See this one. Given that the mirror is concave mirror and object is placed at a distance of 10 centimeters, at a distance of 10 centimeters, and focal length of the mirror is 15 centimeters. Okay, so object distance, you know that object distance or image distance for concave mirror, it is measured from the pole, whether it is the concave mirror or convex mirror, it is measured, all the distances are measured, okay, from the pole. So you are measuring the distance in the direction opposite to the direction of the incident ray. This is the direction of the incident ray, but you are measuring along this direction. Are you clear? So given u is equal to minus 10 centimeters, u is equal to minus 10 centimeters. At the same time, you are measuring the focal length from pole. This is the direction of the focal length you are measuring, but this is the direction of the incident ray. So you are measuring the focal length in a direction opposite to the direction of the incident ray. So f is equal to minus 15 centimeters. Now you are asked to find v is equal to how much. You know that 1 by f is equal to 1 by v plus 1 by u. So substituting the values, 1 by focal length is minus 15 is equal to 1 by v minus 1 by 10, 1 by 10. So now make v as the subject. 1 by v is equal to minus 1 by 15 plus 1 by 10. Now what is the LCM for 10 and 15? The LCM is 30. 10 3 ja 30, that is 3. Next 15 2 ja 30. So 2. 3 minus 2 divided by 30, which is equal to 1 by 30. 1 by v is equal to 1 by 30. If 1 by v is equal to 1 by 30, then v is equal to how much? 30 centimeter. So, what is the image distance? The image is formed at a distance of 30 centimeters. 30 centimeters. Now, if you observe carefully, V is equal plus 30 centimeters plus 30 centimeters. So, what is the nature of the image? Nature of the image is virtual and erect. Virtual image and erect image. Why? Because see, in the case of virtual image only, observe this one. What is the nature of the image? Virtual and erect. Here V is equal to, what is that? Positive. V is equal to positive. This happens in the case of virtual images. So, what is the nature of the image? It is virtual and erect. Now, formed behind the mirror at a distance of 30 centimeters from the pole. Where is the image formed? The image is formed at a distance of 30 centimeters from the pole. 30 centimeters from the pole. Are you clear about that one? So, virtual image means it is formed behind the mirror. It is formed behind the mirror. So, this is the case we studied while drawing the ray diagrams. When the object is kept in between pole and focus, you will get the virtual image. The image is formed behind the mirror. I think I made this problem crystal clear to you. Let us do an let us do this sum. This sum is given in annual examination in SSC and CBSC and various boards. The sum is also important for various competitive examinations. An object of 4 centimeters height is placed at 25 centimeters in front of concave mirror of focal length. What is the focal length? 15 centimeters. Once again, you read the sum. An object of 4 centimeters height is placed at 25 centimeters in front of concave mirror of focal length 15 centimeters. At what distance? At what distance from the mirror would a screen be placed? Would a screen be placed in order to get a sharp image? In order to get a sharp image. Okay. So, what is given here? Height of the object is given. Next, what is that? Object distance is given. Focal length is given. At the same time, you are also asked to find the nature of the image and size of the image. That is nature of the image and size of the image, height of the image. Are you clear about that? So, first write down the values given. What is given here in the sum? It is given that height of the object HO is equal to height of the object is equal to how much? 4 centimeters. Height of the object is given 4 centimeters. Is it plus 4 or minus 4? You are always measuring the height of the object above the principal axis. So, as per sign convention, Hy is equal plus 4 centimeters. Next, object distance is minus 25 as per sign convention. You are measuring the object distance from the pole. So, it is opposite to the direction of the incident ray. And focal length also minus 15 as per sign convention. You are asked to find V is equal how much. Now, we know that the mirror formula is 1 by f is equal to 1 by v plus 1 by u. 1 by f is equal to 1 by v plus 1 by u. You need only v. So, make v as subject, that is 1 by v is equal to 1 by f minus 1 by u. Now, substitute the values of focal length and object distance. By substituting the values, that is 1 by v is equal to minus 1 by 15. Next, minus of minus 1 by what is that? 25. 1 by 25. So, here minus into minus is plus 1 by 25. 1 by v is equal to 1 by 25. Look carefully, minus into minus plus 1 by 25 minus 1 by 15. Now, find the LCM for 25 and 15. The LCM is how much? For 25 and 15, what is the LCM? 75 is the LCM. 75 is the LCM. Now, 25 3 ja 75. So, 3 1 ja 3. Next, 15 5 ja 75. So, 5 1 ja 5. So, 3 minus 5 divided by 75. So, 3 minus 5 is 2. 2 divided by 75. Now, V is equal to 75 divided by 2, which is nothing but minus 37.5 centimeters. Minus 37.5 centimeters. Are you clear? So, image distance how much? Minus 37.5. Minus 37.5 centimeters. So, what is the nature here? The nature of the image is real and inverted. Real image and inverted image is formed. Okay. Why? Because, why? What is the reason? Here, what is the sign? Minus 37.5. So, real and inverted image is formed. So, where should the screen be placed? The screen should be placed at a distance of 37.5 centimeters from the pole of the mirror, in front of the mirror. In front of the mirror. So, the screen should be placed in front of the mirror at a distance of 37.5 centimeters from the pole of the mirror. Are you clear about that? See, simply we substituted the given values. So, simple thing, you remember the sign conventions. While solving this type of problems, you have to remember the sign convention. Okay, whether F is positive or U is positive or V is positive. Okay, don't get confused. Don't get confused. Simply you remember the sign convention. So, where should the screen be placed? The screen should be placed in front of the mirror at a distance of 37.5 centimeters from the pole. From the pole. Next, one more sum is there here. You are asked to find size of the image, that is height of the image also you are asked to find. Okay. To find the height of the image, what you have to do? You have to apply the magnification formula. What is the formula you have to apply? What is the formula you have to apply? Magnification. What is magnification? We defined it is the ratio between the size of the image to the size of the object. Size of the image to the size of the object. So, magnification M is equal to HI by HO or minus V by U. Minus V by U. Substitute the values. Height of the image. What is the height of the image? It is now you are asked to find height of the image, and height of the object is given how much? 4 centimeters. Are you clear about that one? So, simply you substitute the values here. Okay. So, when substituting the values, see this one, minus V by U, that is minus 37.5 divided by U is minus 25. This is equal to height of the image you don't know, by height of the object is 4. Substitute the values. So, by cross multiplication, 37.5 into 4 divided by minus 25. So, height of the image is equal to 150 divided by minus 25. 25 1 jar, 25 6 jar. So, height of the image is equal to how much? 6 centimeters. Minus 6 centimeters. Are you clear about that one? So, here height of the image is how much? Minus 6 centimeters. So, what is the nature of the image? Real and inverted image is formed. What is that? Real and inverted image is formed. Size of the image is 6 centimeters. Now, magnification is equal to, that is the height of the image is 6 centimeters and height of the object is 4 centimeters. Height of the object is 4 centimeters. That is minus 6 divided by 4, which is nothing but magnification is equal to how much? Minus 1.5. What is the magnification? Minus 1.5. Let us try to do one more sum. Find the nature and position of image formed when an object is placed at a distance of 15 centimeters from the concave mirror of focal length 10 centimeters. Whenever this type of sum is given, first you draw the diagram. This is the concave mirror and this is the principal axis and this is the pole and this is the focus and this is the center of curvature. Given that the distance between pole and focus is known as focal length. What is the focal length? 10 centimeters. Next, See, where is the object kept? The object is kept at a distance of 15 centimeters, means in between focus and center of curvature. Here given as per sign convention, object distance is equal to minus 15 centimeters and focal length is equal to minus 10 centimeters. You are asked to find V is equal to how much. Now, you know that 1 by F is equal to 1 by V plus 1 by U. Substitute the given values. Now, make V as the subject. So, 1 by V is equal to 1 by 15 minus 1 by 10. This is equal to 1 by V is equal to 2 minus 3 by 30. What is 30? 30 is the LCM. Now, this is equal to minus 1 by 30. If 1 by V is equal to minus 1 by 30, V is equal to how much? Minus 30 centimeters. How much? Minus 30 centimeters. So, where is the image formed? The image is formed in front of the mirror at a distance of 30 centimeters from the pole, at a distance of 30 centimeters from the pole. So, what type of image? Real and inverted image is formed, real and inverted image. See, we also studied that while drawing the ray diagrams, when the object is kept in between focus and center of curvature, focus and center of curvature, the image is formed behind the center of curvature. Here, see, object distance is 15 centimeters, focal length is 10 centimeters, means between P and F, it is the distance between P and F is 10 centimeters, and see this one, that what is that object distance, that is the object is kept somewhere here in between C and F, C and F. Are you clear about that? So, the image is formed behind the center of curvature. Children, here a simple technique to remember the sign conventions. See, in coordinate geometry, you know how to draw the coordinate axis. This is the x-axis and this one is the y-axis. This is the y-axis. Okay, the point of intersection of these two axes, x and y-axis, is the origin. It is the origin. Let us assume a concave or a convex. A concave or convex. This is the concave. This is the concave. This is the reflecting surface. This is the reflecting surface. Imagine the pole of the concave or convex mirror is placed at the origin of the coordinate axis. Origin of the coordinate axis. This is the first quadrant. This is the second quadrant. This is the third quadrant. This is the fourth quadrant. See this one. Here x is negative and y is positive. See this one. This is here x is negative and y is positive. So, the distances which are measured from the pole in the direction opposite to the direction of the incident ray are taken as a negative. So, you are measuring all the distances from the pole. Actually, this is the direction of the incident ray. So, you are measuring in the opposite direction. So, u is negative. U is negative. Object distance is negative for a concave mirror and focal length is negative for a concave mirror. Okay, and image distance is also negative. Image distance is also negative. Are you clear about that one? Next, inverted and real image is formed here. Inverted and real image is formed. Are you clear about that one? Next one, here in the case of convex mirror, this is the reflecting surface. This is the bulged one. This surface serves as the reflecting surface. Are you clear about that one? So, the light rays are coming along this direction. Light rays are coming along this direction, and you are measuring in the same direction of the incident ray. You are measuring the distances along the direction of the incident ray. Are you clear about that one? Except the object distance, the focal length and image distance are positive, So, the object distance is negative. So, in the case of convex mirror, object distance is negative and focal length and image distance is positive. The distance is measured above the principal axis. This is the principal axis. Let us consider that this is the principal axis. The distances measured above the principal axis are positive and below the principal axis are negative. Are you clear? If magnification is negative, we have to remember one thing. What is that? Real image is formed. Magnification is negative means real image is formed. If magnification is positive means virtual image is formed. That is the thing you have to remember. I think children, I made this chapter crystal clear, and I hope you can solve these sums whenever they are given in a annual examination. Thank you very much children.